Welcome CSC103 to our presentation on 3D software and technology, 3D graphics in general. In the Cengage book, it's actually under vector artwork. It's under the first unit that talks about vector artwork, but we kind of went away from that for a little bit to do some other things, but we're coming back to 3D right now, so it's not too much all at once. And we're going to talk a little bit about 3D, and I'd love to start off with my cheesy clip art on the front, but it actually is an example of 3D because not only is it just letters, but it has depth. This is called text that's extruded, meaning it's pulled back so it had some depth to it. And you can see there's shadows, there's highlights, there's even some highlights that make it look like it has a shiny texture on it. There's some reflection down here. So that's all part of 3D. And a lot of times in the end, 3D is about how it looks in the end. But now you're seeing a lot of 3D that is actually able to generate objects, physical objects from your 3D model. So we'll talk about that too. Now, here's the topics we'll talk about. 3D, the application of 3D technology, where it's used, the applications, 3D space, and some 3D terms. We'll just keep it simple in the beginning. I'll show you a couple different examples of software that we're going to be using. Where is 3D technology used? Think about that. It's used all over. You probably see it on TV and in movies for years, Toy Story, things like that. In games, if you do gaming, you've seen 3D around for a long time. It's being used in healthcare and medical, being used for prosthetic devices. You've seen it with police, being used to recreate crime scenes. It's in design for a long time. It's obviously used for architecture, engineering, manufacturing. And like I said, the fact that you're able to generate objects, to generate products from your 3D models that you can build and actually print out and have a physical 3D product from it. So that's where a lot of things are going with 3D. Now, 3D software, here's just some names. This might mean something to you, it might not. Things like Maya, 3D Studio Max, Carrera, SketchUp, ZBrush. Bryce was an older one that you can make environments like clouds and mountains and lakes and stuff. It was pretty cool. Blender is a free 3D software that I've used in 3D classes, and I'll show you in this presentation a little bit about Blender. And very full-featured, but it's free. And Vectory is one I've used in the past that was online. And they kind of pushed a little bit to the pro version and made it very hard to use the free version. So we're going to be using something called TinkerCAD, which you may have worked with, but it's very simple, and I think it'll be a nicer introduction to 3D. And it'll be very easy to share our files, and it'll be very unintimidating as far as using it. First, before we talk about 3D and the software and everything, let's compare it to 2D. We've worked with 2D software. We've worked with Photopea, we've worked with Gravit, which are the Illustrator and Photoshop counterparts, and in those programs, we basically work with XY coordinates, 2D. You know, we could kind of go up and across, and that's all we can do. What we have as a finished product is really just a picture. Even though we could work with multiple layers and things like that, it's really just a picture. And this is an interface for Gravit, and you can see we just kind of had Y going up and X going across. And we did put in drop shadows, we did put in gradients and things to make it look like it's more 3D on our apple and pear and stuff like that, but it really was not. It was 2D, and I don't think anybody could be fooled to think that it was an actual photograph. And actually, a photograph is a photograph. That's 2D. So you're actually just capturing life. You're not really getting 3D out of that. So that's 2D. Now, 3D gets a little more complicated. This is Blender, and this is an interface in Blender, and you can see there's a kind of a grid floor in the background. There's a cube in the middle. There's an x-axis that's going along the red line. There's a y-axis going along the green line. That's kind of like a piece of paper. If you took a piece of paper and turned it to the right, picture it being, you know, the top of the paper being in the upper right of the screen there, something like that. That's the way the paper is, and the Z is coming up off the paper. So if you think of 2D being a piece of paper, you know, where you're just drawing on it with a pencil, think of 3D if you threw some clay on there. Then that's 3D. Or if you had something coming out from it, that's 3D. So that's more space to deal with. That way you can work around all sides of it. So it does get a lot more complicated. The software is more complicated when you're working in 3D, as you can see from this, and I'll show you some more of Blender in just a second. Now this is Vectory. We used this in previous semesters. It's nice software. It's free online. You could do a couple projects that you could keep in the cloud online, but like I said, it was pushing for a lot of pro version kind of stuff, and it wasn't allowing us to share our files that we were doing for free. So that's why I looked up TinkerCAD. But Vectory was cool too. So it's a nice 3D online program if you like working with it. It has all these little spikes coming out from the cube there to move it around and rotate it and scale, but but it still works on a grid, and it still has the XYZ kind of view there. And this is a perspective view. I don't know if you could see it that much on this slide, but the lines on the grid will kind of go back and kind of get closer in perspective. They'd have vanishing points, if you ever learned about vanishing points, and that's what perspective view is. And we'll talk about perspective view and orthographic view. And this is TinkerCAD, and you can see we're viewing this plane from the front, and there's the XYZ coordinates. There's X going across, just like a piece of paper, just if you held a piece of paper and looked at it, and Z is kind of coming up from it. So that's what we're going to work with. This will be a little simpler to work with, but we're still going to have those same planes, and we're going to throw a ruler on the work plane there so we can position things. That's TinkerCAD. That's just another way of looking at the interface that we're going to work in. And you can see that this is perspective because obviously it's going back. It looks like a kind of trapezoid shape, but that's the flat plane going back in space. And 3D software typically will have a grid, which we just saw. It may have a camera so that you can take a picture of what you're doing, kind of like a director on a movie set. We could kind of move around and look at everything and set everything up, but then from the cameras where we'll actually take the finished picture of what we want. And usually the finished product of 3D is something 2D, like a movie or like a picture or something like that. We can also set up light sources. We could use these mesh primitive shapes, just like we did with Gravit, where we worked with ellipses and rectangles and things like that. We'll work with spheres, we'll work with cubes and cones and cylinders and shapes like that. We'll start with simple shapes and then build them into more complex shapes. And here's a view in Blender. Here you can see the camera, the grid, the cube, and the lamp. But rather than just looking at the slide, I'm going to go into Blender a second. Here's the actual software, Blender. And like I said, this is free software. You could download it for Mac and for Windows, and you can use it for free. Now, you might think, why aren't we using this? Well, look at it. It would take us weeks just to get familiar with working around. It's not very easy to first start using. As a matter of fact, I've used Blender for many years before, and they just changed the interface. They have a new version, and I'm somewhat lost in it. I have to really look around to find out where things are at, so I don't want to do too much here, but here's a live view in here, and one thing you could do in 3D programs is you could kind of move around and circle around. I'm just moving my fingers on my laptop. In some cases, you might have to hold a key, but I'm just moving around like that in 3D space. You can hold modifier keys and to kind of move up and down. They have tools over here to kind of zoom in and out. You kind of slide to zoom in and out. They have a hand tool where you can kind of move it back and forth and go up and down. And we'll learn how to do that with our keys even when we use TinkerCAD. And they even have a camera view. So here, this thing is the camera. There's the camera, and it's over there. So I'm like the director, and the camera's over there. Here's a light source right here. I could click on this light source, and here's my primitive cube. So these are all the things in my scene. And if I wanted to view through the camera, I could go over here, and that's my camera view. And that's what it looks like. And I'd have to use the camera controls to kind of make it rotate up and down or side to side, things like that. So, that's what we're dealing with in here. The zooming, moving around, it can get very complicated very quickly, even to just take a simple shape like this and move it. They have tools over here, and you can see that the blue means I'm moving it on the Z axis. The blue is the Z, so I'm moving it along like a pole, the vertical axis, which is the Z axis. If I want to move it along the Y axis, I'm moving it that way along the Y-axis. And you don't always have to have it locked in, but that's what I'm doing right now. That's movement, but then you can also rotate things. You can also rotate, like if it's going around a pole, that's rotating around the Z-axis. You could make it rotate around the X-axis, like the horizontal bars. And same thing with the other way, with the Y-axis. So you could rotate around all those different points. You can scale. They have a scale tool, so you can scale all these different points. You could scale it in one direction, in all directions, all different kinds of things you could do here. But because you're going in 3 directions, it does get more complicated. So anyway, that's our view in Blender, which we are not going to use, but I just want to show you how that works. Again, I mentioned orthographic. Orthographic is straight on. Perspective is at 3/4. If I go back to Blender, just one second here, this is perspective. And if I went to view orthographic, you could see that's more straight on view. But there's also views too, where if you view things from the top, and you could view from the side and all those different things. Actually, it'd be easier probably to go back to TinkerCAD. If I viewed from the top, there's the cube from the top. There's the view from the right. There's the view from the left, and so on. And that's orthographic. I'm not seeing any perspective here. If I put it in perspective, let's see which one I'm in here. It says switch to perspective. This is perspective. So if I hold down my control key, you can see I'm seeing some depth here. You can see these are going off in the distance. And if it's in flat view or orthographic view, you can see there's no perspective there. But the orthographic views, when I say straight, I mean when we're viewing from the front, because that's how you'd see if things are lined up perfectly. You'd have to view from the front. Let's say you're flying over a city and you need to know where things are at. You'd need a top view. So you'd be looking at buildings and roads and stuff from the top, just like if you were in Google Maps and you were looking at the satellite views from down. That's how you would see things, but you wouldn't see depth. You wouldn't see how high buildings are or how high trees are or anything like that. You wouldn't see any of that because we're looking down on the z-axis. We're seeing x and y just like a piece of paper right now, but we're not seeing the z-axis. So again, ortho, just like braces. When you get orthodontics, that's straightening. So orthographic is the straight views. Typically, that's the front, back, left, right, top, and bottom. And you can also look at it at 3/4, but it won't have any vanishing points. Perspective will have vanishing points, and it'll make it look like you can see some depth there as well. And here's an example from Blender. I mentioned Blender. We've done this in the past in other classes where we can actually model an apple and pear. Sound familiar? Like we did in Gravit? Well, this is doing it in 3D. And it's starting with a sphere and maybe another sphere that we can actually like stretch up, I think, a little bit we used. And then we could put colors on them. We could put light sources, all that kind of stuff. Here's a 3/4 view or perspective view, so now we could see depth. So now they start to look a little more realistic because we see highlights, we see shadows, we see it in space. We put little planes behind there, so we put it next to a counter sort of with walls behind it, so it looks like it's on a kitchen counter or something like that. We start to build something like that, put some lights in there so we get lots of nice light. And again, we build these things out of very simple shapes. So they started out of a shape like this, a sphere. That's how we built our pear and apple out of that. So just like in Gravit, we're starting with very simple shapes and kind of working from there. And that's what we'll do when we start to learn about 3D. We'll work with very simple shapes and build some other complex shapes. Well, actually not complex shapes. We're not going to build anything that complex. Maybe a pumpkin, something like that. We'll see. All right. And also I want to mention this too. This is really what 3D modeling is. You can actually go in and edit the vector points. Now, even though it's 3D, there still are vectors underneath. It's kind of like a mesh underneath. Or even if you've ever worked with sculpture or anything and you had a wire mesh underneath, they work like that. And you can move these things around just like we did with the anchor points in 2D and Gravit. You can do this in 3D. So we kind of like pull in this stuff to make it more of a pear shape, to make it taper and things like that. So these are what actually makes the 3D model. When we could go in here and start to pull in the top so it looks like there's a little, you know, where the stem is and where the bottom of the apple is, that makes it more realistic than just being round on the top and bottom. So we can do all that by editing all these little pieces and all these little vector shapes that's part of 3D. And then finally, once we start to render, we can do things like put different textures. Here's a tile texture on the background. Here's a wood texture on the counter. Here's an apple texture, a realistic apple texture. Now, it's not a picture of an apple. We actually have to use a texture so that it wraps around. And then it could repeat going around. If you've ever used tiling for anything, you don't want to see where it starts and ends. This pear right now does not have any texture on it. It just has a material. So this is called a material. This is called a texture over here. And obviously, once we do a texture, we can even have bumps in them. So the light source will make it look like they have indents or they're raised. There's a lot you can do with 3D. Here's a finished version, and we actually put a texture on here where they have little bumps on here, just like a pear would, and little bumps on the apple, just slightly. And by putting light in here and shadows, you could really make a neat scene. What's cool is this is created out of nothing. I mean, we just built this just like we did in Gravit, build an apple and pear, but this was built in a 3D program. And we set up lights, we set up all this, and it's all artificial, which is kind of cool that you can do that. And another thing I want to mention here is animation. In Blender, if I go back to Blender, they actually have a timeline down here where you can do animation. Animation can be done by having a camera move around a set and, you know, go around objects and move around. Or you can actually move the objects, have the camera be still and have objects move, almost like take multiple pictures, like frame by frame animation. So there's a lot of cool things you can do. Blender actually has very full-featured animation capabilities and video capabilities. I've even seen this recommended as free video software. You could bring in video clips and stuff like that in here. You can actually do video work with it. It's not easy. I'm not gonna look at this interface. I'm telling you, this is not easy. The minute you click on something disappears. So it's a very complicated interface. This is not Gravit or Photopea at all. Even though it may look like it, The minute you start clicking on things, it could change in a hurry, and then you'll be like, whoa, what happened? Like if you render this, if I go here and I'll just render my image, and it's going to render this picture of the cube from wherever my camera is, and there it is. That's where the camera is. Now it doesn't look like much right now because I don't have any colors or anything, but right away you're like, well, what happened? How do I get rid of this? And you have to close this little window and go back, and the minute you start clicking on some of these things here, everything changes. So it's not for the timid to just jump in here and say, hey, I'm going to try this out. But if you have time to work with it, it's a very cool program to work with. But people who do this spend a lot of time doing it. People don't just dabble for, I'm going to spend 15 minutes messing around in Blender. You really have to invest in some time and watch some videos and things like that. And again, that's why we're going to use TinkerCAD, because that will be much simpler than working in this kind of interface. And again, the final slide here on the PowerPoint, just about through here, is about 3D printing, because TinkerCAD is set up so you can build 3D models and print them out with materials. And I don't have a lot of experience doing that. I'd like to, and if you have any experience printing out 3D models and things like that, you can certainly share them with me, because I haven't had an opportunity to do that yet, although I think it's awesome that you can do that, and hopefully that's something we'll be doing in the future at some point in one of our programs. But that's where TinkerCAD is set up to do things like that. If I go into TinkerCAD and they have all these shapes over here. Not only do they have basic shapes, but they have connectors, they have all kinds of things. We're just looking at basic shapes, so they have connectors, they have dinosaurs and all kinds of things, and gears, all kinds of things that you could build here. So it can be used for engineering and all kinds of stuff like that. So it's a really cool program, which is where the CAD comes in, because it's computer-aided design is what that means. What CAD means is computer-aided design, and that's kind of what we're doing here. So you could do fun stuff, you can make characters. They have characters. You can go in here and make a chicken character, robot, different stuff here, so all kinds of stuff. It may be kid stuff, but it's a good place to learn about working in 3D space. So we won't do anything fun like that. We won't be making characters. We'll be just putting, blocks and circles on top of each other. Maybe a pumpkin. If you're lucky, we'll do a pumpkin. But anyway, that's 3D. That's our little introduction to 3D, and we're going to explore it for a little bit in this unit in CSC103.